This is the week 6 workshop. My name is TG Sido. We're going to learn a lot today. So let's get started. Okay. So go to the description. You'll see a link for this notebook. Go ahead and open that up and you'll see starter pack link. You'll see be sure to follow setup instructions from video before running the notebook. So we actually went over all the setup steps in the last video, in the lecture video. That's also linked in the description. Go ahead and click that. Watch it if you have not already done the setup steps and then come right back here. Okay. And so right now we'll actually run this cell. Hopefully it runs. Hopefully it runs. Okay, and now we're at the authorization step. Let's go ahead and click this. And I'll select my account. Allow. Copy. And now let me paste the code. Hopefully it works. Hopefully it works. Yes. Okay, so we're good right here. Now let me run this cell. This has a link and 2 file names. And let me load this image object. Cool. And now for the owl. Let's go. And now for the white wall. Hey, okay. So we're all good now. Let's move on to the tasks. So write a function named task1 that accepts a link to an image, handles all pixels as follows. Set every color component to its inverse. So if the red component value is k, the inverse component value is 255 minus k. Okay, so repeat for the green and blue components. And finally returns the modified image object. All right, so let's start this. Again, we do have our link stir over here. So we will use something like this. We'll say image is equal to my image. And then we want to say load image from link and pass in link stir. Oop. And now we want to go through every pixel and modify it specifically so each of the color components is set to its inverse. So for pixel in image, we'll say pixel.red is equal to, and now we'll do 255 minus pixel.red. And so we want to continue this for the green and the blue components. So I'll just copy this over here. And let me put in green. Green over here as well. Blue. And blue over here as well. And finally, what do we need to do? We need to return the modified image object. So we've actually been changing or modifying the pixels in the image. Let's actually return that modified image. So return image. And so again, as a recap, we're basically going through all the pixels and then changing the color components to be set to their inverse. So let me go ahead and run this. And now let me test this out. It's kind of slow. It's kind of slow. Hey, okay, that looks good to me. And then remember, this is what the original Christmas image looked like. So it looks like we are seeing the inverse as expected. A lot of holiday Christmas cheer. All right. Okay, now for task 2. So write a function named task2 that accepts a file name for an image, handles all pixels as follows. If the average of the pixel's RGB values is greater than 175, then convert it to a purple pixel. And note that purple in our setting will be defined as follows. Red 75, green 0, blue 130. And finally returns the modified image object. Okay, so let's get started. So we'll have this image object over here is equal to my image, and we'll pass in this file name. Okay, and now that we have this, we have our image object. Let's actually go through each of the pixels and we'll check the average. If it's greater than 175, let's make it a purple pixel. Okay, so for pixel in image, let's check the average. First, we need to compute that average. So we'll say average is equal to, and we'll have pixel.red plus pixel.green plus pixel.blue. And finally divide by 3. Okay, and so now we have the average and we'll check it. And we'll say if the average is greater than 175, what do we need to do? We need to convert it to a purple pixel. Okay, and so to do that, we need to change the red component to 75, green component to 0, blue to 130. So let's do that over here. So pixel.red is equal to 75. Pixel.green equals 0. Let's set that to 0. And then pixel.blue, let's set this to 130. Okay, so we've done that. And in the cases where the average is not greater than 175, we just don't touch the pixel. So now that we've done this, at this point in time, we know that the image has been modified. We actually need to return the modified image object. So we'll say return image. Okay, so we're good to go here. Let's run this and let's test it out. Okay, just as expected, we have this basically now a purple wall, and this is the original image. Ooh. And so knowing that white typically has a really high component values for red, green, and blue, this is expected, and basically we're turning all of this purple. And now for task 3. So write a function named task3 that accepts a file name for an image, handles all pixels as follows. If the pixel is in quadrants 2 or 3 and the average of the pixel's RGB values is greater than 175, then convert it to a purple pixel. And note that purple in our setting will be defined as follows. And then if the pixel is in quadrants 1 or 4 and the average of the pixel's RGB values is greater than 175, then convert it to a yellow pixel. Note that yellow in our setting will be defined as follows. Okay, and now finally returns the modified image object. And here's the quadrant layout. So we have quadrant 1 over here, quadrant 2, quadrant 3, quadrant 4. And so it says hint, use helper function to determine if a pixel is in a particular quadrant. So we'll actually hit this first. And let me actually open up my slides from the workshop. These will be in the description as well. Over here, what we see is that the upper left corner is our origin, that's 0, 0. And so that's up here. And the center point, or the star, is actually at x is equal to width divided by 2 and y is equal to height divided by 2. So let's actually use width divided by 2 and height divided by 2 with floor division instead. Why are we doing that? So if the width is 5 and we just do 5 divided by 2 with regular division, we get x is equal to 2.5, right? And we know that we have no pixels at decimal locations, but we do have pixels at x is equal to 2. And we do have another pixel at x is equal to 3, right? So we can actually apply this same reasoning. And one way to actually think about this grid setup to actually help us get closer to determining whether a pixel is in quadrant 1, 2, 3, or 4 is to actually use halves. So we'll say the top half, that'll be where y is between 0 and height divided by 2. And so specifically over here, what we're saying is we know that y is equal to 0 is over here, and then we get all the way down to height. So saying that y has to be in this range, basically all the way up to height divided by 2. So y must be in this top half. And then the bottom half, right, is y is between height divided by 2 and height. And so this is height divided by 2 going all the way down to height. So this will be the bottom half. And now over here for the left half, this is for x. We actually have that x must be between 0 and width divided by 2. So we know that x is equal to 0 is over here, and x is equal to width is over here. And so width divided by 2 is this midpoint. So the left half is basically saying x is between 0 and this width divided by 2. So this is the left half, and then the right half is the other side. So x must be between width divided by 2 and width all the way over here. So this would be the right half. And so we have some helper function is in top half. We have is in bottom half, is in left half, is in right half. We'll focus on these first. And so for top half, we have these parameters. We have image, x, and y. And so we will need to use some image properties, but basically we want to use this expression and basically check, is this particular xy in the top half? And so what we can do over here is return, and I'll basically use this expression. I will need to make a little change though. I will need to say image.height, right? Because we don't have access to height on its own. But I do know that this is a property, so I can use image.height. And so what we're saying over here is this will only return true if this expression is true. So y would actually have to be in between 0 and the image height divided by 2. And so we can continue this pattern for these other helper functions. And so now let's do the bottom half. And so let me do this. I'll say return And instead of height, I need to have image.height. And over here, same thing. And so this one is good now. Let me now focus on the left half. So it's good when you plan this out, it makes it a whole lot easier. So is in the left half. So let me return. And instead of width, I need to say image dot width. And so now, again, basically this is saying that x happens to be between 0 and the halfway point of width divided by 2. And now for the right half, we can use this. Oop. Okay. And so now instead of width, again, I need to use image.width. So give me 1 second. All right, so now that we have these, let's actually go to the quadrants. How do we determine if a particular XY is in quadrant 1, 2, 3, or 4? So let's actually go over here. And so what do we notice? Let me make this a little bit smaller. Okay, so what do we notice about quadrant 1? So it's in the top half for sure, and it's also in the left half. So let me actually use these helper functions over here. So what I'll do is I'll say return is in top half, and I'll pass in my image, my x and y, right? I need to pass in the correct arguments. And then also over here, I need to check, is it in the left half as well, right? It needs to be in the left half. So let me actually copy this and I'll just change that top to be left. Is in left half. Let me move this over a little bit. Let me make this a bit smaller. Okay, so now that we have this, let's actually do this for quadrant 2. So in this case, it's also in the top half, but it's in the right half. So I'll just change this a little bit. And so this is in the right half, right? So it's in the top half, but also in the right half. Now let's check this for quadrant 3. This happens to be in the left half and also the bottom half. So over here, I can actually just use this. Okay. And so again, it's not in the top half, it's in the bottom half. And it is in the left half. So this is good for quadrant 3. Now for quadrant 4. It is in the bottom half, but it is also in the right half. So I will change this to be right. Okay, and now that we have our helper functions, let's continue. Okay, so over here, we want to use this file name and actually create our image object. So image is equal to my image, and we'll pass in that file name. Now over here, we actually want to iterate through all the pixels. Let's actually use the nested for loops. So over here, we'll say for y in range, and we'll pass in image.height. And we'll say for x in range, and we'll pass in image.width. Okay. And now that we're here, we're going to have our particular x and y. Let's actually get the pixel at that particular xy location. So we'll say pixel is equal to image.getPixel, right? We're using this method. And we'll pass in our x and y. Now that we have our pixel, let's actually calculate the average for the RGB values. And so we can use this from up here. We will actually need to use this average check as well. So let's get this. And now that we have the average, right, we do want to check if it's greater than 175. Why is that? So over here, we basically said that we wanted to change or convert the pixel into a purple pixel if the average of the RGB values is greater than 175 and it's in quadrants 2 or 3. And in this case, we're also checking if the average is greater than 175. So we do need that check. And then later on, we'll actually check to make the determination about its location in the quadrants. So we have that over here. So right now, if the average is greater than 175, we know at this point in time, we do need to convert the pixel. It's either going to be purple or it's going to be yellow. So let's actually make the determination and check if it's in quadrants 2 or 3. Remember, again, 2 or 3 is to actually change the pixel into a purple pixel. So let's actually use our helper functions. So we'll do this over here. So if the pixel is in quadrants 2 or in quadrant 3, right? We know we need to convert this pixel into a purple pixel. So over here, we can actually use this above. Remember, the purple definition is the same as in the previous problem. So you can just use this. It'll go a little bit faster. All right. So now let's put this over here. We're actually changing the color components. And so now we are creating our purple pixel. Now over here, let's actually check. Is this in quadrants 1 or 4? So if the pixel is in quadrants 1 or 4, and we've already done the average check, let's actually convert this to a yellow pixel. So we can use our helper function again. I'm just going to use this over here and just change that to 1 or 4. Oop. So 1 or 4. Okay, now in here, I need to actually convert this pixel to be a yellow pixel. So how is yellow defined? Red 255, green 255, blue 0. So let me actually change the color components in here. So red should be set to 255. Green should be set to 255. And blue should be set to 0. Sorry, blue. Okay, so at this point in time, we've actually changed, well, I should say over here, at this point in time, once the loops are done, we know that we've changed all the pixels that we should change, right? So if the average is greater than 175, we check. Is it in quadrants 2 or 3? Let's actually make it a purple pixel. And then if it's in quadrants 1 or 4, let's make it a yellow pixel. I should put this comment over here. And so we've done that. And so once we're done and we're out of these loops, we know that we can actually return the modified image. So let me just say return image. So we're all good to go over here. Let me run this. And now let me test it out on the white wall. Moment of truth. Hey, okay, we got it. Okay, and now for task 4. So write a function named task4 that accepts a file name for an image, creates a new image where all pixel positions are rotated 90 degrees clockwise relative to those in the source image, and finally returns the rotated image object. So we have our owl over here, and we're actually trying to get over here to the rotated owl. Okay, so the goal is to determine the mapping or formula from x, y in the original image to x prime, y prime in the rotated image. And so we have a toy image grid over here. And so this is our original image. We have our x and our y. The height happens to be 4. The width happens to be 3. Again, this is a toy example. And then over here for our rotated image, we actually have height and width swaps. So height is 3 over here, width is 4. And then we have our x prime and our y prime. And so what we can start off with is this. For every pixel, list out the position within the image and its corresponding position within the rotated image. So using this notation, right, we have the pixel val and then image x and y and then rotated image x prime, y prime. So we'll start off with A, which happens to be at 0, 0 in the original image. And so we have A, image 0, 0, cool. And now over here in the rotated image, where is A? It's at x prime is equal to 3 and y prime is equal to 0. And so we see that over here, rotated image 3 and 0. And now for B, this happens to be at x is equal to 1 and y is equal to 0. We see that over here for B, 1 and 0. And then over here in the rotated image, its location is x prime is equal to 3 and y prime is equal to 1. So we see 3 and 1 over here. So you want to continue this for all the pixel values. This is actually going to help us determine the formula. Okay, so we have a really, really funky color scheme. What is going on, TG? What are we doing over here? So we see this purple and this purple, okay? And also having listed all of these values and all the locations, you may have noticed there's a little pattern. Okay, we see this 0, 0, 1, 1, 2, 2, 0, 0, 1, 1, 2, 2. And so we see that there is a relationship between x, right, which is this, and our y prime, which is this, okay? And so if we look at this, we see that in this particular case for purple, where x is equal to 0, this 0th column in the original image becomes the 0th row in the rotated image. And you see that again over here, right? So the x is equal to 2 for the second column in the original image becomes the second row in the rotated image. So keep that in mind. We see that x from the image is always the same as the corresponding y prime from the rotated image. Okay. And now over here with this color scheme, what are we seeing over here? It's very, very funky. Okay. So we see with blue, this last row, which is at y is equal to 3, becomes the 0th column in the rotated image, right? And that's x prime is equal to 0 over here, okay? Now the second to last row, which is at y is equal to 2, this is green, right? Becomes the 1th column in the rotated image at x prime is equal to 1. And we see the same thing over here in yellow, where y is equal to 1 for yellow, for this particular row. And then over here, we see x prime is equal to 2. Okay, and then same thing over here for this orange row, where y is equal to 0. Now the x prime over here in the rotated image becomes x prime is equal to 3. And so we have this over here. We do see that there is a relationship between the rows in the original image and the columns in the rotated image, but there's something flipped, there's something wacky there. So what is that? Okay, so seeing all of this basically is translating what we just saw. We see that there's this relationship between y and x prime. And you may already see the pattern, but let's actually hit this home over here. So from a couple of slides back, we know that y prime is equal to x. We already made the determination over here, right? Now over here, we said that there was a relationship between these rows and the columns over here. And so this is how we're actually getting that. So what we see over here is that x prime is equal to the rotated width minus 1 minus y. And then specifically, we know that the rotated width is 4. So we plug that 4 in over here, and we have x prime is equal to 4 minus 1 minus y. So that's basically saying x prime is 3 minus y. And so let's actually take that back and see if this matches up with our intuition. So 3 minus y. So if y is 0 over here in the original one, right? 3 minus 0, that's 3. So we get our x prime. That seems good. Okay, now we need to do 3 minus y. If y is 1 and we do 3 minus y, we get 2. So our x prime is 2. And so we see that over here. Sorry, that's over here. So we have our y is equal to 1, right? And so we do 3 minus this 1, that gives us 2. And so we see over here for x prime is 2, we now see this column. And so everything is matching up. And so basically this is the formula that we can use to actually perform this rotation. Knowing where our x and our y is, we can actually determine our y prime and our x prime. So we know where to place that pixel. Okay, so now that we have all of this, let's actually go back to the notebook and implement it. Okay, let's use that to actually implement task 4. So over here we have our file name. Let's actually create our image object. So we'll say image is equal to my image, and we'll pass in that file name. Okay. And now we actually want to create our blank canvas for our rotated image. But first we need a width, we need a height. So we'll say rotated width, and this is going to be the height of the original image. It's kind of swapped, it's kind of funky. Okay. And now for our rotated height, this is going to be the width of the original image. So remember, it is swapped. Now we can actually create our blank canvas for the rotated image. We'll say rotated image is equal to my image dot create blank image, and we'll pass in that width and the height. So we'll say rotated width, and now rotated height. Cool. And now let's actually iterate over the pixels from the original image and put them in the correct position in the rotated image. So we have 4y in range, and we'll say image.height. And now for X in range, and we'll say image.width. So now that we have this, let's actually get the pixel at that particular XY in the original image. So we'll say pixel is equal to image.getPixel, and we'll pass in the X and Y. Now that we have this, we actually need to determine the X prime and the Y prime, and we have that formula. So what do we have over here? So we say X prime is equal to what? We have rotated width minus 1 minus Y. So we can say rotated width minus 1 minus Y. And so that's good. Now we have our X prime. What about our Y prime? So Y prime is equal to X. So that's it. That's all that we have to do. We just took it from here. And now that we have this, we actually need to put this pixel at that X prime, Y prime in the rotated image. So we want to have this rotated image dot set pixel. We want to pass in the X prime and the Y prime. And we want to put that pixel there. So what are we really doing? So just to recap, we basically are getting the pixel from the original image at XY. And now we need to determine the X prime and the Y prime. Where is its location in the rotated image? So we got the X prime and the Y prime, and now we're setting, basically taking that pixel from the original image, and now we're putting it at X prime, Y prime within the rotated image. Because again, the rotated image started out blank. We actually need to put pixels in the appropriate locations. So now that we have this, once this is done, rotated image will be populated. It'll be completed. But we still need to return this rotated image object. So we can just say return, and we'll say rotated image. So everything looks good to me. I think we got it. Let's actually try this out. Okay, and as expected, we have our rotated owl image. Remember, this is how it started out. So this is what we had at first. Now it's rotated. We're good to go.